this video, I'm going to explain conjugate of a complex number, its geometrical representations, then properties with some examples. So if Z is a complex number, its conjugate is represented as Z bar. Z is x plus iy, its conjugate is x minus iy. So you have to change the sign of the imaginary part. Here plus, here minus. So if it is a minus, here it will be plus. For another, Z is equal to x minus iy, then Z conjugate will be x plus iy. Here there is an example. Z is 3 plus 2i. So its conjugate will be 3 minus 2i. Negative of a complex number is different. Negative of a complex number, you have to change the sign of both real part and imaginary part. Minus x minus iy. So its negative of this complex number is minus 3 minus 2i. Now let us see its representation. Complex number can be represented as a ordered pair of numbers. For example, this complex number 3 plus 2i can be represented as 3, 2. Then its conjugate is 3 minus 2i, so it can be represented as an ordered pair 3, minus 2. So this is Z conjugate. So conjugate of a complex number can be considered as a mirror image of the complex number. Now let us see some of the properties of complex conjugates. Here, conjugate of the sum is equal to sum of the conjugates. This item you are adding, then finding the conjugate. This side, first you are finding the conjugate and then adding. So conjugate of the sum is equal to sum of the conjugates. Similarly, this is here difference. Conjugate of the difference is equal to the difference of the conjugates. This is conjugate of the product is equal to the product of the conjugates. Here dividing Z1 by Z2, then taking the conjugate. Here taking the conjugate, then dividing. Both are same. Now Z2 should not be 0 because we are dividing by Z2, so Z2 should not be 0. Proof for the first one is given. Now let the first complex number Z1 is x1 plus iy1, Z2 is x2 plus iy2. Add these two complex numbers, Z1 plus Z2. So when you add the real part first plus imaginary part. Then here I is common outside, so y1 plus y2. Then take the conjugate. When you take the conjugate, you have to change the sign of the imaginary part. Next, you take the conjugate of first complex number, Z1 conjugate. So you have to change the sign, plus will become minus. Then similarly, conjugate of Z2, you change the sign. After taking the conjugate, you add. Now conjugate of Z1 plus conjugate of Z2. So add these two. When you add real part x1 plus x2, then minus common outside, I common outside, then y1 plus y2. You can see that these two are same. That means conjugate of the sum is equal to sum of the conjugates. Similarly, you can prove the other properties. The fifth property, real part of the complex number is equal to Z plus Z conjugate by 2. It's a proof. Z is equal to x plus iy. So its conjugate will be x minus iy. You add Z plus Z conjugate. So x plus x, so 2x plus iy minus iy, it will get cancelled. So z plus z conjugate is 2x. So from this we can write x is equal to z plus z conjugate by 2. Then x is the real part of the complex number. So for x we can write a real part of the complex number. Real part of z is equal to z plus z conjugate by 2. Sixth property, imaginary part of the complex number. Z is equal to z minus z conjugate divided by 2i. Let z be x plus I y. Then its conjugate is x minus iy. You subtract z minus z conjugate. So x minus x, so 0. Then iy minus iy, so it will become plus iy, so it will be 2iy. Now from this we can write y is equal to z minus z conjugate by 2i. This y is the imaginary part of the complex number. So imaginary part of the complex number is equal to z minus z conjugate divided by 2i. Seventh property, z raised to n conjugate is equal to z conjugate raised to n. This side you are raising to the power n, then taking the conjugate. Here this side we are first taking the conjugate, then raising to the power n. This it will be equal. Eighth property, z is real if and only if z is equal to z conjugate. We are using if and only if. The reason, if z is real, z will be equal to z conjugate. If z is equal to z conjugate, it will be real. That's why we are using if and only if. Suppose z is 8 plus 0i. Z conjugate is 8 minus 0i. You can see that it is equal. Z is same as z conjugate. So when z is real, z is equal to 8 plus 0i. 8 plus 0i is 8. That means z is a real number. Now z is purely imaginary if and only if z is equal to minus z conjugate. So your z is equal to 5i. Its conjugate is minus 5i. Here it is real part is 0. So it's a purely imaginary number. So now you can see z is equal to negative of the conjugate. So this is 5i, this is minus 5i. So z is negative of this. This is plus 5i, this is minus 5i. So z is negative of z conjugate. Then 10th property, z conjugate is same as z. 2 times if you are taking the conjugate, it will be same. For example, z is 3 plus 4i. You take z conjugate, it will be 3 minus 4i. Once again you take the conjugate, it will be 3 plus 4i. So you can see 3 plus 4i. That means z conjugate will be same as z. 3 plus 4i, 3 plus 4i. So z 2 times if you take the conjugate, it will be same. So it is z conjugate is equal to z. I hope you have understood the properties of complex conjugates. Thank you for watching the video.